You're welcome back to this channel. So in today's class, I want to explain what limit of a function is. So if you are given any function f of x, let's say it's equal to x cubed minus 1 divided by x minus 1. We all know that for this function to be defined, x minus 1 must not be equal to 0. If it is equal to 0, this will be undefined. And we want our function to be defined. We want its value to be a real number. So, for example, let's use graph to explain it. Let's say we are dealing with a straight linear equation, or so at this point, it means that the function is not defined at this point. Let's say it's 2. Let's say it's 2 here. So that means the function is not defined here. So we cannot find the value of f of x or y here. So, but we can find the values of any number that is very close to 2 from the left. And we can also find the value of f of x from x, the number that's very close to 2 again from the right. So if you find that value, so this side now will be defined. This one also will also be defined. So let's call this side that the function do not define. Let's call it L. So where it is defined, there will be some one positive number will be here in between here and here. So we call that one 2 minus delta. So from right hand side it will be 2 plus delta. So in order not to confuse us, let's use alphabet to represent these two. So let's use x. So let's use x here. Use x here as well. So now if you now want to find this side, it will be L plus epsilon and then L minus epsilon. So if you want to find this one, you can, so the function will be defined from this place, that is the left limit of the function, and it will also be defined at the right of the function. So let's now define it mathematically. Let A be a point in some interval x, that is the input, which is subset of real number. Let f of x be a function which is defined at every point of x except possibly at A. At A. It's not defined at A, like this one. It's not defined at x here. So it will be defined at all values of x except at this point. At this point. So let's use A so that we will not confuse ourselves. So it doesn't exist A. It's not defined at this point exactly. Now, then the limit of f of x as x tends to A will now be equal to L. If for any positive number, however small, there is a number which is delta that is greater than 0, such that the absolute value of f of x minus L is less than epsilon for all 0 less than absolute value of x minus A less than delta. So now we can define the limits like this. If you want to define limits like